Right. Hello, everyone. Uh, we can send robots to many different places and spaceships to Mars, but PowerPoint takes a little bit longer. All right. So I'm going to talk about a new exciting area that you may have been hearing about in different places called artificial intelligence, and that is about how we can design systems, computer systems that are intelligent and that can do and perform tasks for humans. And this is a very exciting area. This area is touching our lives every day in different forms. And I will give a few examples of that today for two particular domains, which is cars and robots. Um, we, have, we interact with these robots and systems in a lot of different places. When you drive a car, a lot of the systems in the cars are actually adapted to your preferences. A car has to do certain things according to the way you want to. We already have a lot of these systems in the car. In order to make a lot of different robots, such as in industry, in rehabilitation or social interactions, in grocery checkouts or in homes, work with humans, we have to develop a method or a computer program to make them work with humans to perform tasks. Now, the challenging part is that these robots come in such a large different variety, and they encounter so many different situations that it becomes extremely challenging to make them work. And the requirements of making them work are significantly higher. For example, if you are driving a car, a mistake in a computer program in a car, in an intelligent system in a car, can cost you a lot. Same thing is true for other robots. These robots have to interact many different scenarios. So let me take one particular example of a robot attempting to perform a task for a human, and we will go through why is it very hard to make it work. And this example is of a home robot that we will start with. And the situation here is that
Take some coffee in a cup, add ice cream of your choice. Finally, add raspberry syrup to the mixture.
So what we saw here is that we were trying to build a robot that can listen to a human's command and perform a task. And consider that as an example. An intelligent system has to behave in a similar fashion throughout different spaces, such as industry automation, smart cars, or our homes and offices, where it has to interact with a human, interpret what the human has said, and then perform tasks according to what human wanted. And now that becomes extremely challenging. And for example, let's look at the first example, which is take some coffee in a cup. Now, if you tell that sentence to a 2-year-old toddler, that would become extremely hard for a toddler to do. Like what a 1-year-old or 2-year-old toddler can make out of the statement, take some coffee in a cup. Same is true for a robot. If the robot does not have the context or it does not know what exactly that statement means, in a general setting, it is very hard for the robot to figure out what to do with the command, take some coffee in a cup. So let us think through it. What does coffee mean? Like if you actually go online on a search engine and search for coffee, you would come up with the result, coffee is a brown or black bean, or it's a black liquid. That is what a robot would try to understand when it is trying to interpret the sentence, take some coffee in a cup. But if you look in this environment, there is no coffee bean or a liquid in this particular environment. So robot may just return, hey, I don't know what to do with it. So how do we as humans perform this task? We actually take this statement and look into the environment on what that sentence may mean and interpret the sentence in a certain way. We extend its meaning. We have seen a lot of times people making coffee. So we understand that this word coffee may actually mean that coffee may be contained in this container or in this barista machine in the back. And even if there may not be a cup in the environment, but there may be other utensils such as this mug or this bowl which could be used to have the coffee. So we have to interpret this sentence into the context of the environment. Now, one can program this robot to do this particular task. What becomes challenging is to build a robot that can go out into the wild and perform tasks for us. That is very challenging. So in order to make this happen, what we need to do is to make robots learn, just like humans learn from a lot of their experiences. One way that we learn is by watching people doing things. So we can have the robots do the same. So one thing we did is that we asked the robot to watch YouTube videos and many other videos that are in the internet. So whenever a human asked the robot to perform a task, the robot simply goes to millions and tens of thousands of videos on the internet and just watches them and tries to figure out what is going on. Now, if the robot is watching a lot of videos, there's a lot of information on the internet. So we have built machine learning algorithms that just by watching the video can start understanding the meaning of the words grounded into the real visual signal. For example, in this case, someone was talking about, and for me, the perfect thing to move the eggs around is a little spatula like this. Without any labeling given to the robot was able to figure out that move means moving this spatula here. The eggs are inside this container, and a spatula is this thing. So this is just one example of particular examples of the thing that robot was able to figure out by watching the videos. And by doing that, now the robot can actually interpret these sentences. It can take these commands and then figure out what does taking coffee in a cup means and adapt to this particular scenario. So in this case, the robot decided that to take coffee in a cup means that go to that container, operate that container with that handle to put the coffee in it, and then there is some ice cream lying around. Then it has to, again, extend the meaning. We did not tell the robot that scoop the ice cream with a spatula. That is what it is attempting to do it by itself, and not very well. We have still a little while to go. And then it adds the raspberry syrup, and that gives it to the robot. So a question for you guys, like what can go wrong with this approach if we have a artificially intelligent robot go into the wild and go online, watch YouTube videos, watch WikiHow recipes, crawl the internet on Wikipedia, and try to do things for the humans? There are certain ways in which things could go wrong. So learning by watching is only one way that we have to make intelligent systems work. The second part is learning by doing. And in this example, I'm going to show you something that kind of went wrong in the beginning. So when the robot was trying to figure out how to use a knife, it did not understand that knives are sharp objects in the beginning. And if you leave that robot into the wild, that's not the right thing. So safety and a sense of constraints in which the robot should operate are also a very important part in making these intelligent systems. And such questions come up again and again in many different scenarios. So here what we are seeing here is that robot is now trying to, it knows something to do, and then it's trying things out by itself. And it's trying to get feedback from humans. Is something that I did is good, or is it bad? So human is giving him hints by correcting his motion, by teaching it like the way you teach a child, or you teach someone play tennis. They try to play something, they try to do something, you correct them. So that is another form in which a robot can learn things by feedback. And now the robot kind of knows how to move a sharp object in presence of humans. So by learning, by watching and doing, what we have done is that we have built a really large knowledge engine or knowledge base for robots. So think of that as a search engine for robots. So many of us use search engine or YouTube videos to perform our daily life tasks. Like we don't know something, we go online and search for it and do the tasks. So this is a similar idea for the robots. If we build this giant database for robots, then the robots can learn something, upload it to this internet for robots, the knowledge they have learned, and some other robot can again use it. And this is the vision behind our project, in which we are making this knowledge engine called RoboBrain for robots that has collected this large repository of information that the robots can use. And one thing that I'm very excited about is that because we have built this large knowledge engine which has learned from different sources, robots from all over the world can learn from each other. So very recently we demonstrated that one of our robots at Cornell University was able to learn something new about how to operate that ice cream and other tasks, and then transfer that knowledge through this cloud robotics or internet of robots called RoboBrain to another robot at Brown University. And now we are doing a lot of these things. So the development of artificial intelligence can get very, very fast. Now I will quickly show you just very short video clips on how we can take this idea and apply it to many different robots. So one of these robots is how to make a coffee machine, to make coffee using a barista machine. So this robot has not seen a coffee machine at all in the past, but it can still know how to operate it by learning from different robots from a giant online repository of information and deliver to you a espresso. Here is the last example where the same idea applies to cars, where a intelligent system is trying to help a human save lives. So what happens is that humans can get distracted and they don't have the whole sense of information. But our intelligent system knows better. It knows that there is a bicyclist on the right-hand side, and which it has seen through a lot of data on the internet and by experiments. And when in a real situation, when the person is actually driving the car, it can use our knowledge that it has learned. The car can use the knowledge that it has learned, predict what may happen in the near future, and safely tell the driver in order to avoid that possible accident. So these are just a few examples of what we can do if we take the philosophy that robots need to learn the knowledge, which many of humans do as they are growing up, but also share the knowledge, which in the course of human civilization, if you kind of look at it from a longer perspective, when printing press and libraries happened, one human being was able to take his lifetime of knowledge, share it with another human being, and the progress became much faster. It turns out that robots today do not have this capability, and that is what we are doing at these universities, at Cornell and Stanford University, to enable these robots to learn things, share it with one another, to create systems that can perform tasks for humans in different environments, like rehabilitation robotics, saving lives in cars, making industry automation safer, and so on. Thank you.